Hello dear students, hope you are doing well. Today I am going to explain a new lesson, chapter 5, lesson 3, mathematics for 12th grade, which is integration methods. So in lesson 1 and lesson 2 we studied the definition of integration and some rules for finding definite or indefinite integration. But it's not enough to solve all the problems. Okay guys, so basically we know that the integrate x dx is equal to x squared over 2 plus c. And also, the integrate e to power x dx is equal to e to power x plus c. Now, if we have, let's say, example 1. Find integrate x e to power x dx. It means that the multiplication between these two functions. Is it equal to x squared over 2 e to power x plus c? No, because when we take the derivative for this part, we didn't get that part. Because we know that the differentiation is an inverse operation for integration, or the integration is an inverse operation for differentiation. That's why it's not correct. Also, we have many cases like integrate x cosine x dx, integrate, let's say, x linear x dx, or let's say x integrate x squared plus 1 square dx, and so on. So to take the integration for this function is not always easy task compared to the calculation of differentiation. That's why. But we have several methods deals with these cases. One of them is integration by part. One of them is integration by part. So the formula for this function, for this rule, the formula for this rule is going to be integrate u dv is equal to uv minus integrate v du. So also it's famous by u dv rule, okay? So if we have two different functions, between them the multiplication, I'm going to apply this formula. So most of the students, they ask me, how do I select the differentiation part and how do I select the integration part? This is the very important questions. So to answer this question, always try to choose u so that its derivative less complicated than it is, or choose u to be the function that most easily differentiable, to make easy differentiate. Or some teachers or mathematicians says that choose dv to be the function that most easily integrable, to make easy integrate. Both of them are correct. But here I'm going to choose u is equal to x. If you look at here, the differentiate of x is equal to 1. It's less complicated than itself. That's why, guys, that's why I'm going to choose u. That's why I'm going to choose u is equal to x, and then automatically dv is going to be e to power x dx. Be careful, dv always include dx. Okay guys, now here we have u. We need to find du. So I'm going to take the differentiate du by dx is equal to 1. When you make cross product, we will get du is equal to 1 dx. So du equal to dx. And also we need to find v. So I'm going to take the integrate for both of them, both sides. We will get v. The integrate of e to power x is also e to power x. Now I'm going to use this information to solve the example 1. Okay guys, so the integrate, guys, the integrate x e to power x is equal to dx. Okay, dx is equal to, first step, it tells us u. Our u is equal to x, and then v. Our v is e to power x. Then minus integrate v du. Our v also e to power x, and then du. Our du is equal to dx. Okay guys, then you have to keep the first term x e to power x. We just keep it, and then bring and then you will take the integrate e to power x. So we know that the integrate of e to power x is also e to power x, then plus constant integration, which is c. Be careful, guys. Sometimes in the baccalaureate exam, in general exam, they didn't give you this answer. That's why I'm going to choose e to power x as a factor. So the remainder, we took the e to power x, the remainder is x. And then we took e to power x, the remainder is 1. And then plus c. This is the solution for the example 1. Okay, guys. Some students, they ask me, this is a little bit complicated. We have another method, which is tabular method. Or we can say DI method. Or sometimes say fast way. It's not fast way. It's an integration by part, but in other form. Okay, guys? So we know that u is equal to x. The differentiation part is equal to x. We have differentiation and integration part. Okay? So our differentiation is equal to x. Then we take differentiation is going to be 1. And then we will continue until we will get the 0. Is the differentiate of constant term is 0. And then the integration part, our integration part is e to power x. Also, you have to take integration also e to power x and then e to power x. We will make cross product between these two columns like this. And then the sign will be positive and negative. Now it's easy to take the integration. So the integrate x e to power x dx is equal to x multiply e to power x. And then this is minus 1 multiply e to power x, also e to power x, then plus c. By the same way, you have to take e to power x as a factor. So the remainder is x, then minus 1, then plus c. If you look at here, we got the same result. They're same, okay? It's up to you. Whatever you want, you can choose it. But this one is a little bit easier than that one. This is the formal way, okay? According to this rule, you can solve this. Okay, guys, we have many kinds of example. Let's start with the check it out, okay? Check it out, guys. I'm going to start with the check it out. Check it out tells us find, integrate x squared ln x dx. Okay? Okay, guys. To solve this, check it out. First step, you have to choose u and dv. Okay, it's clear that the differentiate of ln x is going to be 1 over x. It's less complicated than it. And the integrate of x squared is going to be x to the power 3 over 3. Okay. Oh, guys, the choose dv to be most easily integrable, guys. So the integrate of x squared is easy. But if the integrate of ln x is most complicated. Also, we need to find another u dv. Okay, that's why I'm going to choose u. To choose u is equal to ln x, and dv automatically dv is going to be x squared dx. Okay, now it's clear we have to find du and you have to find v. Okay, so now I'm going to find then du 1 over x dx. And then the integrate of v is equal to x cubic over 3. Okay. Now I'm going to apply u dv rule to solve this. Check it out, guys. I'm going to apply this u dv rules to solve this. Check it out. Then, so solution. The integrate of x squared ln x dx is equal to uv. Okay, guys, our u is equal to ln x and v x to the power 3 over 3. Then minus integrate also v du. Our v is x to the power 3 divided by 3, and then du is equal to 1 over x multiply 1 over x then dx. Okay. Now, guys, I'm going to find this integration. We just keep the first term. We bring down this one. We can make commutative rules. It's going to be x to the power 3 over 3 ln x, then minus. If you look at here, this term, you will see that there is a cancellation between these two terms, okay? x with x is cancelled out. So this integration became x to the power 2 over 3 dx. Also, then guys, we keep x to the power 3 over 3 ln x minus take 1 over 3 outside of integration, okay, because it's constant term. 1 over 3, then integrate x to the power 2 dx. Now guys, I'm going to solve this integrate. Now it's easy to take the integrate for this term. Now here we have x to the power 3 over 3 ln x, then minus 1 over 3. We know that the integrate of x to the power 2 dx is going to be x to the power 3 over 3 then plus c. Guys, also we can make a simplification with this theorem. It's easy. It's going to be x to the power 3 divided by 3 ln x minus numerator time numerator is going to be x to the power 3, and denominator time denominator is going to be 9, then plus constant integration, which is c. So this is the solution for the checked out. Okay guys, from here we can take x to the power 3 over 3 as a factor, x to the power 3 over 3 as a factor. The remainder is ln x. Okay, minus, we took x to the power 3 over 3, so the remainder is 1 over 3, then plus constant integration, which is c. Both of them are correct, guys. Thank you so much. I hope this lesson will help you to understand the integration by part. Thank you so much.